EC50 or IC50 determination is a tedious job if you want to do this in Excel, unless you know what to do. Why is it so complicated? Because behind those observations are usually curves of the S-shaped form. They are called sigmoidal or logistic, and those equations are not the easiest kind. So I will try to explain how you can do this if you are dealing with Excel. First, some terminology. EC50 is the concentration of a drug that gives the half-maximal response. EC is the effective concentration, IC is an inhibitory concentration. It's just a matter of terminology, it's semantics. Let's see that in a real situation. We have found these observations. These are the logarithmic versions in column A. Those are the average compound values. And we want to predict what those values would be. These are the observed observation points, and you see they are of the sigmoidal or logistic type. How can you connect these dots with a curve? One of the formulas or equations that would be very helpful is this one. Take the exponents of the slope times the x value minus the inflection point divided by 1 plus the exponents of the slope times x minus the inflection point times the saturation point. The saturation point is something like this. And because the curve starts at 0, I don't need any more. If your curve has been shifted upwards, you have to add plus the shift value. In our case, I don't need that. I came up already with this inflection point, which is basically the IC value, which we are supposed to find, but let's assume we have it already. This would be the slope, in my opinion, and that would be the saturation point. Based on those values, I can calculate my predictions. I did that already in this situation. I put in C7 this equation, and the formula would look like this: equals exponents, etc., divided by 1 plus the exponents times the saturation point. And these are the values we found, and you see that the curve nicely hugs the observation points. Of course, there are always some residuals, some aberrations. We will work with that later. Now the issue is, I could actually ignore that red curve. It's just to show you that the equation would do the job. I'm going to find the halfway point. The halfway point should be somewhere between these two values, and we want to find the corresponding value between those two. How do we get the halfway point? It's basically a simple formula. In this cell B16 we put the value B15 low plus the difference between high and low divided by 2, and that gave me this point. It is somewhere between these two guys, and we want to look now what would be the corresponding value for those two guys. So we would like to put here an insert that shows me that point of IC50 or EC50. If you want to make that insert, you need 3 sets of coordinates. This set of coordinates, that set of coordinates, and that set of coordinates. I put those sets here. The first one is very simple, the first cell, that is the highest value, or the lowest, and that one is the opposite one. The real problem is this one. It's not really a problem if you know what to do. That is the value that corresponds with 32,290. Correct? What is the tool we need? The trend function. The trend function says, what are your known y values? A10, go A11. Your known x values, these two guys. And finally, your new x value, that is the halfway value that you want to find, and so you are trying to find this one by using the linear trend function. And it found minus 9.59. Notice that that is very close, probably the same as that one, but rounded. So what is the corresponding? If we follow this formula, and I think we should, then it should come up with that point, if the curve is correct. Correct? So I have in here the calculation, exponents divided by 1 plus the exponents, etc. So I added one more feature, which is really redundant, but just to show you that everything works correctly. At this point, I would like to see where is that 50% point. So I put in here a formula that is shown in this row. You probably don't care about it because you usually won't need it. When you copy that formula downwards, then you will find out that this green curve gives you the percentages shown on the secondary y-axis, and the 50% spot is right there. I'm going to apply this knowledge to a different situation. In this case, we have concentrations of the logarithmic type, and here are the compound values. And I use not only our formula that we have been using so far, the simple one I call it, but also the Boltzmann one and the logistic one. They are three different models. I showed you here what those three modules calculate. These are the three equations that we could use for sigmoidal slopes. Sometimes one is better than the other, it depends on your data. Sometimes one of them may not work. In this case, probably all three will work nicely. So we are going to create predictions according to three different models, and this is the outcome. Notice that the three curves nicely coincide with each other, and they also nicely fit the observation points. How did I do that? First of all, because the concentrations are of the logarithmic type, I created a new column A that takes the natural logarithm of all these concentrations. You do that with the function ln, the natural logarithm function. You copy those formulas down and you plot those on the horizontal axis. So these are the linearized versions of the concentration. Then I use my formulas. The first one in D6 uses the Boltzmann model, so it uses this equation, and it does that with this formula. And all the others do something similar. When you want to just see one of them, you can hide column E and F, and you will only see Boltzmann. Then you can hide D and show only E, and finally F, etc. And you will see that all those curves usually nicely fit. Some situations may not have the perfect fit. We will deal with that in another way. So now the final issue: how do we get that EC50 value? We could use our previous method with the trend function, etc. There is another way which is probably a little easier. Say I came up with an EC value based on eyeballing 0.5, which is not correct, as you can see, because the curve doesn't fit. You can do trial and error. I think there is a faster way. What we are going to do is we are going to calculate the sum of the least squares. That is a very common value for curve fitting. What does it do? It takes the difference between the observed value and the predicted value, squares it, and does the same for the next one. The difference between observed, predicted, squares it and sums all of them. I try to do that in one formula. C6 through C15 minus D6 through D15 to the power of 2. So it does basically this. It takes that column, subtracts from it the values in that column. The differences are stored in an internal array. All those differences are going to be squared, and finally we sum them. So that is what they call an array formula. It does things with internal arrays. So if you don't accept that formula correctly, you will get an error. I accepted it the normal way and I got a value issue. Why? Because this is an array function. So I have to accept it like all array functions with Control-Shift OK. And then it gives me the right value. That sum of the least squares value should be as low as possible. So how can we make that as low as possible? By setting this to a minimum with the tool Solver. Solver is a great tool to do this kind of trial and error situations. We set D16, the sum of the least squares, to a minimum by changing the cells D2 and D3, which is the slope and the EC50 value. And when I click on Solve, it found a solution and set this back to 22, and it said the EC50 value is 0. That curve fits much better. So my EC50 value is right here, which corresponds with a concentration of 1. There is much more to sigmoidal curves. You can find more in my book. There is much more to be found, either on 2 CDs, Excel 2007 for scientists or Excel 2013 for scientists. They contain more than 1800 slides. You will be interrupted sometimes by questions to make sure that you got everything, and if you choose the right answer, you can go to the next slide. You can also go, if you don't like those CDs, you go for my books, Excel 2007 or Excel 2013 for scientists. They do the same issues, but on paper. Depends on what you prefer. They have the same contents. First they discuss general spreadsheet techniques, then data arrays, including array formulas. How do you plot your data, including histograms, error bars and interpolation? How do you do curve fitting and regression? That's what we were doing here basically, but also for linear, non-linear situations, multiple regression and correlation. And then it has a huge chapter on statistical analysis for the student's t-test, the chi-test, analysis of variance, how do you test for significance, and how do you calculate margins of error. You can find all of this on mrexcel.com, amazon.com, and just search for my name, Gerard Verschuren, at amazon.com, and you will find all these beautiful tools that will help you to do your scientific work. I wish you good luck.